Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson, grade 10 algebraic expression, and in this classwork set, we're now looking at the second part of can you convert decimal fractions to common fractions. Most of the time this is tested via recurring decimals, right? So let's go first and see if you understand the following. So decimal fractions 0,3, 0,75, 0,845, etc. These are referred to as decimal fractions. Common fractions as a numerator and a denominator, so 4 over 10, 7 over 8, 12 over 40, 96,784 over 100 or no, 10,000, right? These are called common fractions, right? So we must be able to convert decimal fractions. We need to understand the place value of each after the comma. So 0,3 is the same as 3 over 10. Right? One decimal after the comma, meaning 1 0 with 1. So therefore 3 over 10. They have two decimal places or two digits after the comma. So my denominator would be 100, meaning the two values, two zeros and 1. So therefore 75 over 100. If I look at three digits after the comma, denominator is 1000, so that's 845 over 1000. Three digits, three zeros with 1. Four digits after the comma is represented the denominator of 10,000, meaning I have four zeros and the value 1 and 9678 over 10,000. So those are basics you should have learned from grade 8 and 9. Right? But if it comes to now recurring decimals, we have a different system we're going to work with, and we're going to be shifting these commas. So you have to follow very carefully. So the exam question, if we ask this one, normally 4 to 5 marks, all right? We would say write 0,4 recurring as a common fraction. So that's 0,4. The dot on top means it can be written as 0,4444 going on indefinitely, right? Right, so we'll let x equal that 0,4 reoccurring. All right. Now, we then need to know if we're going to multiply by 10, 100, or 1000 to ensure that we move one natural number to the front of the comma, right? So if we look where the comma is, I need to shift one space to have a 4 in front and not the value 0. So therefore, in this case, because I have one digit after the comma, I multiply by 10. So if I say 10x, then it shifts one space and it becomes 4,44. So this minus that, so we're going to say 10x, equation 2 minus equation 1. So 10x equal 4,44. Negative x equal negative 0,44. So the objective is always to get rid of the recurring decimal. So you see as I've done it there, that comma 44 and this comma 44 can cancel, and I'm left with any rational or real number, or for that matter not rational, I should say any integer. Alright, it's going to be positive or negative. So 10 minus 1 gives me 9x. Comma 44 cancels with comma 44, so 4 minus 0 gives me 4. And then we always divide by whatever's in front of x. So 9x divided by 9 would give me 1x. 4 divided by 9 would give me 4 over 9. So that's first example. Right, by now you should learn that we need to do at least 3 to 7 examples before you fully get the hang of it. So this is just the introduction based on what we would teach you at school. We still have to do some exercises to drill this concept in your head. You get used to doing maths properly. Before you know it, you will become a fundi in maths. So number 2, they say convert 8,46 reoccurring to a common fraction. So what we've given you there, 8,46 reoccurring is 8,464646, etc. Right? So that's given. Let x equal that, right? So from here, we want 146 to come to the front, right? and then the other 4, 6 to stay behind. So my comma needs to move 1, 2 spaces. Ne? Because I have 2 digits reoccurring, my comma needs to move 2 spaces. So each space I move is an extra 0. So therefore, instead of multiplying by 10 like the previous one, now I multiply by 100. So if I multiply by 100, it becomes 846,46 reoccurring, right? So 100 is 846,46 reoccurring, and x equals 8,46 reoccurring, right? So if I subtract now 2 from 1, I have 100 minus x, which gives me 99x, and then comma 46 and comma 46 cancels. 864 minus 8 would give me 838. From there, 99 divided by 99 gives me 1. 838 divided by 99. So x equal 838 over 99. And if I write it as a improper fraction, x equal then 8 and 46 over 99. Alright. So there's a second example. Let's look at the third example. But as I said, we're going to do a lot more examples via the form of exercises. Alright, so 3 convert 1, 0, and it's only 832 to a common fraction. So 832 is reoccurring. So 1, 0, 832 is the same as 1, 0, 832, 832 going on. Right? So first I only want the reoccurring part at the end. Right? So 0 there you see is not recurring, so I need to move this comma 1 space. To move the comma 1 space, I multiply by 10. Right? So 10x would then give me 10, 832, 832, etc. reoccurring. Alright? Then if I multiply now, I have 3 recurring decimals. So I have to put 3 zeros onto 10. So therefore I'm multiplying by 10,000. So I multiply by 10,000, my comma is moving 1, 2, 3, 4 spaces, 4 zeros. So if I look there, 1, 2, 3, 4. So it moves exactly 2 before 832 starts reoccurring again. So that becomes 10,832, 832, 832, 832. So if we subtract 2 from 1, 10,000 minus 10 would give me 9,990x. The 832 and 832 cancels. 10,832 minus 10 would give me 10,822. To make that 1, we always divide by the coefficient in front of it. So 9,990 divided by itself give me 1, and that becomes 10,822 divided by 9,990. That goes in there once and leave a remainder of 832 over 9,990 Rand. So I hope it's clear enough for you, right? As I said, as we work through the exercises that will come up, we will strengthen your knowledge of this. If you're academic, you need to do at least 3 of each one. If you are a little bit lower than academic, by 5 times you should understand it. If you are weaker, you first have to go through the hard work of doing it 6 to 7 times. Do that before you know it. By the end of the year, you'll be close to the 50s and 60%. And eventually, we'll work your way up to the 80 and 90%. All right. God bless. Bye.